And here we are with yet another component that I've been working on and using on quite a lot, just like the scene compositor, and actually they work quite well together. This is BananMash, and the SH is somewhat intended as a name, so I'm not going to change it because it's of course a wordplay on mashed banana. But what is BananMash? It is a finite state machine for Touchdesigner itself. Maybe some words about finite state machines. It basically is a system, a closed system that has a set of states. So in this case, for example, init states and A, D, C, and a state called momentary. And there are connections between each state. And these states do have a time, a length, and they have conditions which can be true or false. And under certain circumstances, you can configure this yourself. You can define when this transition from one state to another should occur and when not. And this way you can build closed systems that are self-containing and incredible stable. So once you have set up a system using a finite state machine, it is almost impossible to break it, which is very important using it in permanent installations where you don't really have the possibility to jump in all the time if something breaks, but instead you have this one part of your project which is taking care of transitioning between states. So maybe let's take a look at what we have in the parameter section first. And then we can jump in, play around a little bit and see how the UI works. And afterwards, I will show you one simple example of how to use it for a permanent installation, for example. So the first thing you have is the state itself. So some information, these are all read-only. So for example, you have mode. And this one is a value, either it's state or transition. And depending on that, we do have different behavior, but you can also, for example, use parameter executes to catch that if you don't want to use the built-in callback system and event system. So this definitely is one possibility. Then we know which state we are currently in. And if we are in a transition, we also know which state we are currently transitioning to. Then we have the fraction of our transition as a value between 0 and 1. So it's normalized, and the same with state, because states also can have time, but we're going to look into that. The next thing is the actual settings page. This is where you set everything up. First thing is the init state. So here you define in which state we want to enter when the whole system initializes. So this means on startup, on restart, stuff like this. And yeah, normally you want to have like an init state component state. And the moment you are done initializing, for example, using a timer to initialize the project, when this is done, then we can check for the condition. And when this is met, then we will move to the next one. Then we have a little set of elements that define how we are working or when we are reacting and checking. And this is check on part change. And check on part change basically means that we are reacting to a parameter change in our data store. The data store is basically these central components where we have a set of custom parameters that we are influencing from the rest of the project. And every time a parameter here changes, then we can react to this change and calculate if we are due for a transition. Then we have the part check mode. So basically the way this one works is either way we check every time a parameter changes in a frame, or we're checking at the end of frame and we're checking all parameters. So this can be interesting if you have a lot of parameters, but what you have to keep in mind then is that sometimes a change in state triggering something different could result in like a recook or actually an ignored check condition. So it's set default to per parameter, but you have to play around a little bit to get a feeling for that. Then we have check on state time. This basically means that every state has also time associated with it. This basically means that every time this state time reaches 0 or 1, or like the done state, then we are doing the check, and depending on that, we're doing a evaluation of our connections. And then we have check on state enter, and this basically means that when you enter a state, then we will do the recheck in the same frame. And this can be a little bit finicky, so to minimize this a little bit, I have this enforced minimum transition time, and this basically means that we are forced to have a transition time of 1 frame so that we can't check the state at least more than once a frame, because then you can very easily create like endless loops in your system, and that could crash the system. So normally if you say check on state enter, you normally also want to enforce a minimum transition time. Similar to my other components, again, we have callbacks that we can create, and these callbacks are then used to react to a state change in a Pythonic way. We do have our data store. So basically this is again a data repository that we're creating externally of the app, of the component, so we can update the component later on without having to worry about our data. And the same is true for state. So these two are 2 separate components. For the beginning, let's maybe start with the data store to get an idea for that. So right now it is it's just a base with nothing inside, but you can extend it, for example, with logic, and then we can also customize the component here to, for example, create a pulse parameter, or in this case like a momentary or toggle or string. All of this is certainly possible. Then the next thing is we have states, and this basically, if we look inside, holds our components that define our states. And inside of these states we have the underscore connections, and in here we have the transitions from one state, from the parent state, in this case A, to our state D. Then we have the callbacks. Let's maybe also take a look at the callbacks. And they basically, so here we have callbacks for if we enter a state, if we exit a state, if the transition starts, if the transition ends, and if we're cycling. Cycling in this case simply means that we all transitions returned false, so we are staying in the extension that we are in. You can also then define custom callbacks that are very specific to specific state changes. So in this case, if we look in here, let's make it a little bit smaller, then we can say we, for example, want to have a change, like we want to have a callback when we enter state A. And in this case, what we can do is we can just copy our state enter here, and then we can put in 2 underscores, and then we put in the name of the state, and then this callback will only execute when we enter the state A. So you don't have to do like if state name equals A, but instead you can like declarative create your callbacks here on the go very easily. So how do we use it? Let's open the UI. For this, we press View, and it's more or less, reactive to your UI. So it changes, and we can even change this window here. So this should all be somewhat understandable. Yeah, so here we have our states, and the states are these little boxes with the name in it. And if we click on it, you see we get a yellow border, and this means this is our currently selected state. So in this case, this one, as we can say, okay, the UI says state, and it gives us the name. Here we again have the name of a parameter, and we have some parameters, for example, to set the duration of the state. Then we have some functionality like destroy and go to, so we can this way force to go to a certain state without respecting any of the connections. So this should be used sparingly. Ideally, the system is completely self-running, so you don't have to take care of any of this. Then here we have a list of the connections. So right now this one connects to A. And if we just click on it, then we are selecting our connection here in this case. So now the arrow has a yellow underlie, and this basically says us, okay, we have selected a connection, and the connection is going from init state to state A, as you can see. So, but we can also just click on the arrows themselves. Relatively easy. And what we then see, again, we have the edit and we have destroy, and we have the parameters. So this is our target. Again, we have a duration, and we have a parameter filter. So basically with a parameter filter, we can define which parameters should be interpreted to trigger a change. This is only used, of course, when you're using the on-par change mode. If you're using the on state time mode, then of course this has no effect. If we look here, we also actually have an order parameter in this case, and the order parameter basically says, okay, if we have more than one connection from one state to several, then this way we can define in which order they should be evaluated, because the first connection that returns a true value or a truthy value is going to be executed and the rest will be omitted. So this way we can say, okay, some connections do have priority over others. And this is the order parameter. Again, we have a duration parameter, edit and destroy. Below that, we do have our function here. We have the so-called check function. And what this one is going to do is it's for one, giving us the data store that we just created as a repository, and then we have the BananMash, like the state machine itself, so we can call certain functionality, but normally we are really just interested in the data store itself. So, and then we are returning a value that is true or false. So in this case, we are returning that not the parameter momentary in our data store is not pressed. So yeah, or in this case, we're just saying, okay, it's true. I always want to have the transition from A to D. And here in the momentary, we are basically saying, hey, okay, we need to press the momentary button. Here's a little comment. And again, we are asking for data store.par.momentary, and we are going to evaluate that to get a truthy value in this case. So how can we manage them? For one, you will see the arrows jump around a little bit to always get like the shortest route. And if we want to delete a connection, we simply delete it. And we can either use the destroy button here, or what we can do is we can just press delete. So I'm going jumping a little bit. I'm going to create a new one, a new connection. And to do this, we just have to drag the right button of our mouse and drop it onto the target state that we want to create a connection to. So again, we created this one. The default will be set to false, same, and the duration will always be 0. So maybe let's delete this again, just to show you that this is possible. Okay, let's create a new connection again. And of course, we can also create a connection back. This then looks like this. And of course, but we don't really want to go back to our init state, so we're just going to delete it. If we want to create a new state, Then we're just going to double click and we open a new window, and we're going to name this one new state. And if you press enter, it will create the new state for us. And again, the same, you can just delete the state by either pressing the destroy button, new state, or by simply pressing the delete key on your keyboard. If you want to move around in your network, especially if it's going to get bigger, then you just drag around with the with the left mouse button. If you want to move a state in the network, then you just also drag it with the left mouse button, and you can use the scroll wheel to zoom in and out, but you can also use the right click. If you right click and drag and drop on the background, so for example, because you're on a touchpad and you don't have a scroll wheel, then you can just use the right mouse button to do that. So yeah, I hope that's somewhat intuitive. So maybe let's go fire this whole thing off a little bit. So first, we are currently in state A, and we're going to give our element here, we're going to give it a duration of 1, so the transition from A to B. And same, we are going to give our states, they already have a duration of 1. And then we will do the same. Here we will do 2 seconds. Here we will do 3 seconds as a transition, and then we will set this one to 0.2. And now if we look into our mode, we have a check on part change and check on state enter. So to trigger this, we can just press momentary, and as you can see, it will now jump around. Like still some smaller visual glitches. That's okay. And yeah, basically here, as you can see, the connection from C to A, we simply have like a randomized possibility of it not continuing. But what we can do here, for example, is we can also set this, for example, we can disable the check on part change and even disable the check on state enter and the enforce minimum transition. We can just say check on state time, and now you can see that the states are moving. So this one has a duration of 0, so it will jump directly after the time is done. But as you can see, because it's randomized, sometimes it works and sometimes not. So we can also look into the check. So as I said, the moment we hit a false, we hit the end and the momentary button is pressed, and we will go into momentary. So let's press the button, and now you can see that we are going into the momentary stage. It will run, and this way we can very nicely influence the system by changing parameters, which should feel very natural to most of us. But we can also do some more involved Python stuff, because for example, we can check if a file exists or not using some simple Python logic, or if a certain time is met, if like the last change to the system is at least 1 minute ago or something like this. So yeah, also the system is pretty efficient. So if we disable the state time and just run on part change, which I do in a lot of projects, and we disable the UI, then you can see that, yeah, it's using a very, very low number of resources to do calculation. So this is just a timer that is running inside. So yeah, I have made a little example here. And this is like a very a prototype of an interactive installation. And this is like the simple activity check. And if we look into here, we do have our init state again. Then we have our idle. And then we have an interactive mode. Then we have okay, that's enough mode, and we have a goodbye mode. So what is this installation doing? Okay, so here we have this installation, and it basically consists of 3 states. We have our init state, and this one will just immediately go to true and go to the idle mode, and the idle mode simply displays a message that says come in, so, or come closer, or something like this. From the idle, we have a connection to interactive. And this one is then basically checking for the player detected parameter from our data store here. And as you can see, the player detected parameter is using a reference to check if our face track parameter is has a valid face basically in the first channel. And this way, if we would reduce the level or increase the brightness to 1 and have a valid face, then we would instantly transition to our interactive mode. The interactive mode then again has two connections. One to goodbye, which simply displays a little goodbye message like thank you for being part of this, or thank you for playing. And it checks if there is no player detected. But because we know people, and sometimes they are very interested in your installation, which is nice, but sometimes other people also want to do it. So we can also, or what we did is we put in a little enough played timer. So if we look into the interactive part, then here we do have a enough timer set to 30 seconds. And then we bind this or reference the start parameter, which is then going to be executed by the scene changer component here. Then we have the enough state, and this one basically tells us, plays a message, hey, you had enough. And then again, we're also going to the goodbye state, and then we're good. And then we are going back to idle after this message was played accordingly. We are then using callbacks, and the callbacks are here in the scene changer. And basically what I'm saying is that every time we enter a state, I want the scene changer to play this state in the transition time, or when we exit. And when we exit a state, I want it to transition to the new state or to the new scene in the scene changer based on the time of the transition itself. So, and I simply named my scenes. I gave them the same name as the states in our state machine here. So we have our idle state. I can just press start here. We have our interactive state, we have our goodbye state, and we have the enough state. So let's see how this looks. I'm going to bypass the level here. And as you can see, we have the player detected parameter is now set to true. And we had our transition, and at the same time, our scene changer selected the according interactive scene here. And yeah, so we're active. And if we look in here, then we have our enough timer that is running. And yeah, let's see what happens if it triggers. That's then here the enough played parameter. It's set to true, and right now it's jumping quite a lot. But yeah, let's see what happens if we now go to we again enable our level. Then we have a thank you for playing that's fading, and then we are transitioning over to our idle state again. And yeah, we can do the same again. And then when a player leaves the field, for example, then we have the thank you for playing that is playing, and we are back into the come in state. So yeah, there are certain ways how we could handle this. We could, for example, in this case, not look into, not have the idle state transitioning right back into interactive, but instead we could also, for example, create a timer and trigger the timer for the idle. Be like, hey, okay, we have like a at least 10-second transition state. Or we could use the state time, for example, and check for the state time. But yeah, this way we have a very, very clear idea of how it works, and it feels quite natural to design an installation and a system this way and create a very stable active system. And yeah, I feel like the most interesting part is actually using this onStateExit parameter, because it gives us quite a lot of flexibility using a system like the scene changer or the scene compositor component that you can find online. Another thing that you also can do with the state machine is using a event emitter. So you can simply take the event listener component here from the OLED, place it anywhere in your project, and just drop it in here. And then if you say create callbacks, you have the same callbacks that you would have just here with the callback manager. So the onStateExit, onStateEnter, and the same as you can also use the underscore methods. So we can say underscore A, or in this case idle. So now we can react anywhere in our project to the idle enter, which also again is quite powerful. If you have larger structures and, for example, don't want to rely on the scene changer or similar systems, but instead you want to control it in point or react to certain events like this. So yeah, I hope you will find some joy in this component. Right now, this version 2 of the Banana State Machine is still in development in my GitHub repository. I will link it down in the link it down in the description. And also, just a reminder, I do have a Patreon. So if you are interested in supporting components like this, or maybe even are using them in your projects commercially, feel free to get in contact with me if you need any kind of addition or you find a bug fix, and we will certainly find a way. But also feel just free to subscribe to the Patreon itself. So see you hopefully there. Bye bye.